All right, working Cal 1 problems, applications of differentiation, their optimization problems. And this particular one here, we want to find two positive numbers such that the product is a 25 and the sum of the first plus 3 times the second is a minimum. So we're going to set up our primary equation, our secondary equation, and then we're going to go through the proper steps to finding these two positive numbers. Okay, so I'm going to go ahead and write out two positive numbers. We're going to let x and y be our two positive numbers. And let's see, we're going to go ahead and write our primary equation. Now, it was the sum of the first, I believe, I'm trying to remember here, it was the sum of the first plus 3 times the second. So 3 times the second. So this is our first and that's our second there. And so now we want to go ahead and write our constraint or our secondary equation. And we said that the product, I believe, was going to be 25. Alright, so we got both of our equations set up. Now what I'm going to do is pretend we forgot calculus. Or let's say we don't know how to do calculus, but we do know how to set this up. Now remember, what we're going to want to do here is we can either solve for x or y in this problem, but I'm going to go ahead and solve for x. Now we're going to take this and plug it in for the y right here. So this s represents sum. You can call it anything you want. Alright, and 3 times, and of course our y is 25 over x, and of course we can actually rewrite this as x plus 75 over x. That's our sum. Now what I'm going to go ahead and do is graph this. Alright, you can see the graph. Okay, so this is 0 on the x-axis and we're coming out to 32 here, and this would be the graph of that sum with respect to x. Now right in here is where we're interested, because this is where the graph, it has a minimum. A minimum is occurring, but we want to find out what is this x value here. That's what we want to find. What is the x value? And let's see, this is 16, so this would be 8, and it looks like maybe just a little bit more than 8 would be our x value. But let's go ahead now and do the calculus. Alright, so the first thing I'm going to do here is I'm going to want to rewrite this, and so we're going to have x plus 75 times x to the negative 1. We want to take the derivative and then solve for x, of course, in this problem. So I'm going to go ahead and take the derivative. Derivative of x is 1. Take this negative 1, bring it out front, and I'll just make that a negative 75. How's that? And x to the negative 2, subtracting 1 from the exponent. Now I'm going to go ahead and just set it equal to 0 and take this x squared down into the denominator, and now we want to go ahead and solve for x squared. And of course, you know, these are the intermediate steps, but I've worked with hundreds, and I guess I could safely say hundreds of students, and this is usually where everybody has problems, and that's just doing the intermediate steps. And you know, once you get the intermediate steps down, I'm here to tell you really that calculus is actually pretty easy, believe it or not. So this is actually a 7 right here. You know, we can actually break this down even more. This is 25 times 3. And you know, these are the intermediate steps. Oh, by the way, remember two positive numbers, so we don't need to mess with the minus sign, right? And square root of 25 is 5. So we can break that down to x is equal to 5 times the square root of 3, which I believe is a little bit more than 8. Somewhere in there. You can plug that in your calculator and check it out. Now remember how to get y. We want to come back up here and say y is equal to 25 over 5 square roots of 3, and we can simplify this down